Assalamu alaikum students. I hope you all are doing well. Today's topic is very interesting and it is multiplication of matrices. Let's see the definition first. Matrix multiplication, also known as matrix product, and the multiplication of two matrices produces a single matrix. If A and B are the two matrices, then the product of the two matrices A and B are denoted by X is equal to AB. Hence, the product of two matrices is the dot product of the two matrices. So by the definition we get the idea that if we multiply two matrices A and B, then we get a single matrix X, and X is equal to AB. This is the way how we denote the multiplication of matrices. Let's move forward. Matrix multiplication conditions. There are some multiplication conditions. Okay, let's read them. To perform multiplication of two matrices, we should make sure that the number of columns in the first matrix is equal to the rows in the second matrix. Therefore, the resulting matrix product will have a number of rows of the first matrix and a number of columns of the second matrix. The order of the resulting matrix is the matrix multiplication order. Let me clear it in simple words. What do they mean? They mean that if we have two matrices A and B, then A's number of rows means M should be equal to the number of columns of B. Only then, if M is equal to N, means the number of, sorry, I wrote it opposite. They say if the number of columns of the first matrix are equal to the number of rows of second matrix. See, the number of columns in the first matrix is equal to the number of rows in the second matrix. Only then the multiplication can be done. Otherwise, two matrices can't be multiplied. As we saw in the previous lecture about addition and subtraction, that the order of the matrix means M into N of both the matrices should be equal. But here, what is the condition? That the number of columns of the first matrix A should be equal to the number of rows of second matrix B. Means if A has two columns and B has two rows, only then they can multiply. Otherwise, they cannot be multiplied. Okay. And the next thing is that when they will be multiplied, the product order will be what? M into N, and M will be the number of rows will be equal to the number of rows of the first matrix A, and N means the number of columns will be equal to the second matrix B. It will be more clear when we will see the examples. Now let's move towards notation. If A is M into N matrix, means A's order is what? M into N, and B is a P into Q matrix. B's order is P into Q. Then the matrix product of A and B is represented by X is equal to A into B, where X is the resulting matrix of M into Q dimension. As we have seen in the matrix multiplication condition, that when the product will be there of two matrices, then its order will be what? M means number of rows of the first matrix here A, and number of columns of the second matrix Q. Okay, fine. Now the next thing is matrix multiplication rules. Don't worry, I'm going to explain all these things with some examples. Okay, for now let's see matrix multiplication rules. The first rule is same as we have studied. The product of two matrices A and B is defined if the number of columns of the A is equal to the number of rows of B. Second is, if AB is defined, then B need not to be defined. Okay, because if you have found A into B, so you don't need to find B into A because it will same answer. Okay, the third is, if both A and B are square matrices of the same order, then both AB and BA are defined. Means if they are square matrices of the same order. What is square matrix? In which number of rows and number of columns are equal. See, if A and B are square matrices of 2 into 2 matrix, 2 into 2 order, both are 2 into 2, 2 into 2, 2 rows, 2 columns, 2 rows, 2 columns, then A B and B A will produce different answers. That is why they both need to be defined. Okay, if they have the same order. Okay, the next one is, if A B and B A are both defined, it is not necessary that A B is equal to B A. Means if we find both A into B and then B into A, then it is not necessary that AB, the answer of AB means the product AB, will be same as BA. They can be different because here values can differ, right? If values can differ and the order of multiplication will be different, because what, rows will be multiplied with the columns first, so the values can differ, and that is why AB can be different from BA. Order will be same, but values will differ in case of square matrices. The last rule is, if the product of two matrices is a zero matrix, it is not necessary that one of the matrices is a zero matrix. Okay, so in the case of zero matrix or null matrix, what will be the case, that always the answer will be zero matrix. But if the other matrix with which first matrix is multiplied is not zero, it is something else, some other elements are present in that it is, and the answer becomes zero, product comes zero. So it is not necessary that always the product will be zero, if and only if one of the two matrices that are multiplied will be zero. No, they can have any values, and obviously when we will calculate their product, it can lead to zero. It is not necessary that always a zero matrix is needed to make a product as a zero matrix. Okay, okay, now we have an example. uh, we have an example, 2 into 2 matrix multiplication. Okay, so here let's consider a simple 2 into 2 matrix multiplication. Here is a matrix A and here is a matrix B. In A, what the order is, 2 into 2, 2 rows 2 columns. In B, 2 into 2, 2 rows 2 columns. Now each of the elements of product matrix A B can be calculated as follows. Okay, now let us see the conditions first. What was the condition? That n of the matrix A should be equal to m of the matrix, means the number of columns of the first matrix should be equal to the number of rows. So the number of columns means 1 2 is equal to the number of rows of second column 1 2, because the first column has two columns and the second matrix has two rows, so they are equal and is equal to m. That is why they both matrices can be multiplied to each other. Okay, okay, now calculate the product. So the first step will be what, that first row will be multiplied with the first column corresponding elements. 3 will multiply by 6 and then plus 7 will be multiplied by 5. Then the first row will be multiplied by second column. Means the rule is that row will be multiplied to the columns, all the columns, n columns, first row, and then the second row will be multiplied with all the columns, and so on. Nth row will be multiplied by all the columns, c1 to cn, c1 to cn. Okay, so the first row will be multiplied with the first column first, and then secondly the first row will multiply by second column, and then the turn comes of second row will be multiplied by first column of the second matrix, and then the second row will be multiplied with second column. Let me clear the board. Okay, okay, so because I need to write here to make it clear, more clear for understanding. Okay, So let's see here. 3 will be multiplied by 6 and 7 will be multiplied by 5. 3 into 6, first two elements means 3 and 6 will be multiplied, and then plus sign will be there. Plus sign will be there because the two products 3 into 6 and 7 into 5 need to be added up to make a single element of the product matrix. Okay, so in the same way, 3 6 3 6 and then 7 5, they will multiply and then added up, and 53 will be the answer. 3 6 are 18, 7 5 are 35. So 35 plus 18 would what? Right, 53. See, 35 plus 18, 8 plus 5 13, 3 1 4 5, 53. The same way, 3 2 the 6 plus 7 8 the 56. 56 plus 8 62. 6 4 the 24 plus 9 5 the 45. 45 sorry. So 45 and 24 will lead to what? 69. This one 62. 4 2 the 8 plus 9 8 the 72 plus 72 will be added up, and it will be 80. So here, first row first column multiplied, first row second column multiplied, second row first column, second row second column. When the first row first column will be multiplied and the answer will be calculated and then added up, the first one element, only one element will be there, and it will be at the first position because first row first column. Okay, first row first column, then first row second column, first row second column 62, this one, and then second row first column at this position, second row first column 69, and then second row second column 80. Okay, now let's do an example. Do another example. Wait, okay, so now we have this example. See, so sorry. Okay, let's do this example. 3 into 3 matrix. Okay, we have the order of 3 into 3 columns, 3 rows, and then we are going to multiply these two matrices A and B. Okay, this is going to be very easy but complex somehow because there are more elements. More elements means more complexity for multiplication. So the rule is the same, that firstly the rows means first row of A will be multiplied to all three columns of B, C1, C2, C3, and then second row of A will be multiplied to all the columns C1, C2, C3. Then third row of A will be multiplied to all three columns C1, C2, C3. Columns of what? Columns of B and rows of A. Okay. Okay, the next thing is here, because it is, they both are square matrices. Square matrices means their order is same, 3 into 3 into 3. So the condition to be fulfilled is that the number of columns of A should be equal to the number of rows of B. So they are of course equal because number of columns are 3 and number of rows are 3. Okay, now let's start the example, the calculation, the product. Let me clear the board first so that I can. Okay, so here is the first row, first row, which has three elements, 12, 8 and 4. And here is the first column which has to be multiplied first, means first row first column, a b 1 1, first row first column. So 12 will be multiplied by 5, 12 into 5, then plus 8 will be multiplied by 6, 8 will be multiplied by 6, and then plus 4 into 7, 136. When we will multiply them these three and then we will add these three, then the answer will be 136. 12 5 is 60, 6 8 is 8 6 is 48, and then 7 4 is 28. When we will add these 60, 48 and 28, answer will be added up to 136. Same goes for the second iteration, in which AB12 means first row second column. First row of A and second column of B will be multiplied to each other, but the corresponding elements, first element from here, first element from here, first element from here, first element from first element, second, second, third, third. Okay, same for the last case, when 1 and 3 means first row and third column. So 12 and 3, 3, and then 8 and 9, 8 and 9, and then 4 and 16, 4 and 16. They will multiply 12, which is 36, 8 9 is 72, and 4 16 is and then they will be added up, and then answer will be 172. Then the turn of second row comes, and then 3 will multiply by 6, second row 2 1, second row first column, see, second row first column, second row 3 17 and 14 will be multiplied with 5 6 and 7. Here 3 will multiply with 5, then 17 into 6, then 14 into 7. For 2 2 3 into 19, 17 into 15, 14 and 8, 14 and 8. Then second row third column, 3 into 3, 17 into 9, 14 into 6. And then the turn comes for the last row. Last row will multiply with all the three columns. First column first, 5 6 7, then 19 15 8, and then 3 9 and 8, 9 into 3, 8 into 9, and 10 into 16. Now as we have got the products, they will be gone to their positions, they will be settled to their positions. AB1 means first row first column, so 136, first row first column, first row second column 380, first row third column 172, and this row then second row first column, second row second column, second row third column, then third row first column 3 2, third row second column 3 3, third row third column. So this is how we calculated the product of two matrices of order 3 into 3. I hope you have got my point and understood the lecture in the best way possible. But if you have any query, you can tell me in the comment section. Let me review it again. First of all, what we saw, we started from definition of multiplication of matrices. Then we saw condition for multiplication. Condition was that the number of columns of the first matrix should be equal to the number of rows of second column, so that the matrix can be multiplied. Otherwise matrices will not be multiplied to each other. The notation was that if A is m into n matrix order and B's order is p into q, so the n should be equal to p. See, n should be equal to p, number of columns of the first matrix should be equal to number of rows of second column, and then when they will be multiplied, the multiplied matrix means the product, that is x, it will have order what, m from a first matrix and q from b second matrix, means its order will be m into q. Number of rows will be equal to the number of rows of a, and number of columns of the product will be equal to the number of columns in b. Okay, and the rules for the we did, the first was same as a's number of columns should be equal to b's number of rows. Second one was that if ab is defined, then we don't need to define ba, but if the matrices to be multiplied are of the same order, and obviously the square matrices of the same order, then both a, b and b and a need to be defined, because the answer might be changed in both the cases. And if a, b and b are both calculated, then it is not necessary that they always will be equal. Okay, they can be equal, but they cannot be equal as well. And for the last one, it was there that if the answer of two matrices, product of two matrices is 0, then it is not necessary that one of the matrices contributing in the product or multiplication was 0 or null matrix. It is not the case. Any matrix can produce a 0 matrix as well. Okay, any non-zero matrices, two non-zero matrices can produce a 0 matrix. Then we saw the example of 2 into 2 matrix multiplication, 2 into 2 matrix multiplication, and then the second one we saw 3 into 3 matrix multiplication. So this was the lecture for today. I hope you will understand it in a much better way, but if still you have any query or question, you can ask me in the comment section. I can give you more examples as well. Thank you so much. Allah Hafiz.